far we've been dealing with slope-intercept form, which I'm going to write up here in the corner, y equals mx plus b. So we usually use that form when we have a slope and a y-intercept. Hence the name slope-intercept form, right? Well, what happens if I don't know a y-intercept and I just know some point on my line? I have this thing called point-slope form, which is right down here. Point-slope form, y minus y1 equals m times x minus x1. Well, x1 and y1 is the known point, the point that we're given. We just plug that into our equation. And it makes it a lot easier having the point-slope form if I'm given the point instead of the y-intercept. Unlike yesterday, we had to go through some algebra in order to find our equation in slope-intercept form. And the funny thing about this point-slope form, which a lot of people don't know, it's derived from the slope equation. So if I think about the slope formula here, it was y2 minus y1 over x2 minus x1. Well, if I wanted to, you notice how this y minus y1 is by itself over here? I could get it by itself in my slope formula. I could multiply by x2 minus x1 on both sides. x2 minus x1. If I did that, these guys would cancel. And I'm going to flip-flop by my symmetrical property. So y2 minus y1 equals, and I'm going to bring my m on the other side, x2 minus x1. Well, what do you notice? That's the same thing as this guy, isn't it? Except I just have y2 and x2 instead of y and x. So that's where that point slope comes from. It just derives it from your slope formula. So let's use this point slope form. I'll show you why it comes in handy. Right here it says, write an equation in point slope form. Well, I'm going to write this down first. So y minus y1 equals m times x minus x1. For the line that passes through negative 2 is 0 with a slope of negative 3 over 2. Then graph the equation. So let's go ahead. I'm going to plug in my slope for m. And then I'm going to plug in this point in for y1 and x1. So this guy's going in for x1. And this guy's going in for y1. So I got y minus 0 equals negative 3 over 2 times x. Well, minus negative 2 is actually x plus 2. So let's simplify that. Minus a negative is adding a positive there. And I'm going to leave it like that for now. And we're going to graph it. So in this case, instead of using the y-intercept, just use the point. Negative 2, 0. I can graph that. And now I can use my slope. Well, it's a slope of negative 3 over 2, which doesn't mean negative 3 over negative 2. So I'm not going down and left because this is actually a positive. Okay, so I'm not using this. I just have to give my negative to one or the other. So I either got to go negative 3 over 2 or 3 over negative 2. I got to pick one or the other. I can use both, actually. So I can go negative 3 over 2, so down 3, 1, 2, 3. Right 2, 1, 2. So there's a point. Remember, rise over run. Or I could use that other one, 3 over negative 2. Up 3, 1, 2, 3. Left 2, 1, 2. There you go. And then draw in my line. And in this case, in my point slope form, minus 0 is just gone, right? I could actually write this. And if you notice, it's almost in slope-intercept form. If I would distribute that negative 3 over 2, it would be in slope-intercept form. So I'd accept either one of those two is fine. You can simplify the minus 0 or leave it there. Either one's okay. So now let's use that point slope form and get it in other forms. So it says, write the following equation in standard form. Well, if we think back to standard form, it was ax plus by equals c. So basically we want to get the x and the y on the same side. And then our constant on the other side of the equal sign, right? The number that's by itself. And we want to make sure that they're GCF, the A, B, and C GCF is one. A couple of just little rules to that. So first things first, let's start simplifying. So I got to distribute this negative 2/3 in order to simplify. So I'll rewrite y minus 1. So negative 2/3 times x. Well, I have negative 2/3 times a negative 5. I'm going to write that up here. Negative 2/3 times a negative 5, which gives me a positive, doesn't it? And that's really 5 over 1. So I get 10 over 3. So I'm going to leave that as a positive 10 over 3. I'm okay with that for now. Okay, so next thing, I want to get the x and the y on the same side. So I'm going to add this 2/3 x over. I'm going to bring it over here. So now we got 2/3 x plus y minus 1 equals 10 over 3. And we want to get this minus 1, so I'm going to add the 1 over here. So I want just in the x and the y by themselves. Plus y equals, well, 1. I'm not going to say 1 and 10 over 3. That doesn't make any sense. So I could make 1 either 3 over 3 and add that on for 13 over 3. Or I could change 10 over 3 to 3 1/3 and then add 1 onto that for 4 1/3. But in this case, I'm going to write that as improper, so it's 13 over 3. I like to leave it improper until the very end at least. So now I need A, B, and C, the number in front of the x, the number in front of the y, and C to have it to be integers too. They have to all be integers, so I don't want any fractions here. So to get rid of the fraction, if I ever want to get rid of a fraction, I just multiply by what's in the denominator. So I'm going to end up multiplying by 3. That's going to cancel my denominator. Well, and algebraically, whatever I do to one side of the equal sign, I got to do to the other side. So when I do that, I got to multiply this whole side. I can't just do it to one term. I got to multiply the whole side to keep my equation balanced. All right, so let's go through this work. So 3 times 2/3, which means the 3's just cancel each other, right? Because 3 times 2/3, the 3's cross cancel, and I end up with just 2. So I'm just going to rewrite that here. So the 3's cross cancel each other. I'm just left with 2x, and then I'm going to distribute the 3 to the y, so plus 3y. And here the 3's cancel, 13. There we go, standard form. Takes a little bit of work. Just following our algebraic rules when we get into that. So you get the x and y on the same side, got to have integers as my coefficients in front of the x and the y and my constant there. Okay, let's do the same thing, except let's get it in slope-intercept form. So now I want to get it in y equals mx plus b form. So I start the same way. I simplify, so I got to distribute. So we're going to times by 4/3. So 4/3 x minus, well, 4/3 times 3. And that's really 3 over 1. And my 3's cross cancel. And so that becomes just 4, right? 4 times 1 over 1, which is just 4. So minus 4. And then we get our y by itself. That's our slope-intercept form. So we got to add 5 to both sides. And that's gone. So we're left with y equals 4/3 x plus 1. Slope-intercept form. So even though I have it in point-slope form, I can get it in slope-intercept form. Okay, a lot of things I can do with these equations of lines. So there you go. A little bit into the point-slope form today. But like I said, standard form, slope-intercept, point-slope, they all just make equations of lines with slope-intercept being the most common.